Good morning, folks, and we are back for our grade 5-6 problem of the week once again. And the problem that we have this week is entitled Fishing for Thermoclines. A lot of folks, especially if you're not used to fishing and working with conservation authorities and lakes and those types of things, may not even be aware of what a thermocline is. And so that's what part of this problem is educating on, as well as turning it into a math problem. So it starts off and it says, Paige is headed to Lac Nago to do some fishing for lake trout and pike. She knows that small pike generally like 18 degrees Celsius water, large pike like 12 degrees Celsius water, and lake trout like 10 degrees Celsius water. She measures the water temperature in the lake at different depths and collects the following data. Plot points to make a broken line graph to illustrate this data. And the first question is, at what depth should Paige be fishing for small pike? B, what depth should she be fishing for large pike? And then finally, Paige knows that most lakes have a thermocline where the water will rapidly change temperature. At what depth is the top of the thermocline in Lac Nago? A couple of things to share with this. First of all, just so that you know, Lac Nago is actually a real place. It is located, if you can see on my screen, right there. And to give you a perspective on where that is, if I go to a much smaller screen, there's Lac Nago right up there still. And we actually access it off of this road out just outside of Fort Collage, Quebec. This road here that follows along, this is actually Jim's Lake Road, and you take Jim's Lake Road all the way up to Lac Nago. And there is located a hunting lodge called Domaine Stoddard, which is, I will warn you now, is my favorite and my son's favorite fishing spot. So that's why we use this particular place. For all the fishermen out there, a lot of people would say there's no way that you could possibly have pike and trout living in the same body of water, and I can assure you they do. Uh, the uh, the design of the lake itself allows that to happen. There are different portions where you have to go, but the pike do live in the bay area, and the trout live more out in the lake area. And so the first question is, at what depth should Paige be fishing for small pike? And the key thing to remember here as we go through this is we have both points as well as intervals. And we need to ask ourselves, what is this question asking? Is it asking for us to define the intervals or for the points? And so at what depth should Paige be fishing for small pike? Well, we know from the fact that small pike like 18 degrees Celsius water, but what do we do with this interval between 1 and 1.5 meters? Or am I using only that space between 1.5 to 2.5? And so that's the big question you need to ask yourself and try to figure out as you're dealing with this problem. The last one is, as we said at the beginning, what is a thermocline? A thermocline, again, defines it as where the water rapidly changes temperature. And the clue that I'll give you here is you'll notice the temperature drops the deeper you go a degree at a time. It goes from 20 to 19, 19 to 18, actually stays there for a little bit, and then drops again to 1, stays the same, drops again to 1. And so if we see a difference after we develop our graph where that interval change is no longer 1 degree, we know we've discovered our thermocline. And so hopefully that helps you with this problem. And as we move into summertime, I appreciated the fact that the Center of Education, Mathematics, Computing saved this problem to the basically almost the very end. We only have one more problem next week. And so happy fishing this summer, folks. And hopefully you'll catch some big pike just like my son and I will.